says, what is the derivative of sine of x squared? Recording? Okay, do that really quick. 5, 4, 3, 2, 1, faster.
Wait, what?
Answer? Yeah, it is cosine of x squared back inside 2x. Okay, that's cool and everything. Now, moments later, a different person walks in to the room and says, hey, what is the antiderivative of cosine of x squared times 2x dx? And you're probably thinking, man, I would have no idea, I would have had no idea how to answer that question, but it just so happens a minute ago I computed a derivative which gives me a hint about how to do this. So what's the answer?
Plus c.
Sine of x squared plus c. That's pretty fun. Okay, another problem. What is the derivative of the square root of 5x cubed plus 1? I'm going to do that right now. Seems like that would be 1/2 5x cubed plus 1 to the negative 1/2 back inside 15x squared. Yeah, do you agree?
Yeah.
Yeah, that's good. That's right. So that's 15/2 times x squared over the square root of 5x cubed plus 1. Moments later, another interloper asks me to compute the antiderivative of x squared over 5x cubed plus 1 dx. And then you say, well, I almost know how to do that. What's going on now?
Now it's stretch.
Just like
Yes, Eob says there are just some annoying constants. And what do you do with annoying constants? You just annoyingly deal with them. In particular, if there were 15 halves here, I would be very happy because then it would be like exactly like the thing, right? So that same teacher who taught me back inside, who was a mean guy, did I tell you the whole story about how he was a mean, terrible person?
Yeah.
Yeah.
We guys watched a video of you telling us.
Yeah, good. Yeah, screw you, Dale Garlic. What's his name? So what I will now do is I will put the 15 halves in. I think that was his name. I will put the 15 halves in, and then we undo the damage with a 2/15 on the outside. And now that I have re-expressed it like this, do you all see that this part of the thing that I'm now anti-differentiating is exactly the derivative of this function? Thus, what's the answer?
Root
5x.
plus 5x.
Wait, you all talked at once, but I hope you said 2/15 root 5x cubed plus 1 plus c. Is that what you said?
Yes.
And if you don't trust me, you can always just differentiate it, and you should get this. And you just will, because, just think about it, right? It just happens, right? The 1/2 comes down, kills the 2, the zoom, the back inside, everything works. All right, so what's up? Yeah, are you good?
For such a bad teacher, he actually taught you a lot. Like.
Yeah, it's calculus, it's still awesome. So, the moral of the story, every problem on this packet, just about, has the following pattern to it. You are being asked to anti-differentiate something, which was the result of applying a chain rule. So you have to be like a detective. You have to look at the problem and notice if it looked like some chain rule happened. So it's like you're like a crime scene investigator. So here is a problem, for example. X cubed cosine x to the 4th plus 2 dx. All right. As a crime scene investigator, Sandeep, does it look like some chain rule happened here? Yeah. Enter the scene. It looks like a chain rule happened. Specifically, can you address why you think it looks like some chain rule happened here?
There's x cubed on the outside of the cosine. There's an an x cubed outside of the cosine.
Yeah.
So it seems like there's like a sine x to the 4th, and then like go back inside for the x cubed, but then like the coefficient, the 4 got taken out.
Yeah, that's right. The inner function, when you take the back inside at x to the 4th plus 2, you get x cubed, give or take a constant, right? And so in fact, what would I like that to be? Instead of 4x cubed, I would like it to be, instead of x cubed, I would like it to be 4x cubed. So I put in the 4, undo the damage with a 1/4. And now, if you're quite smart, you see, haha, pattern recognition, that 4x cubed is merely the back inside of the x to the 4th plus 2. And thus, what function would have this as its derivative? Sine of x to the 4th plus 2, right? Plus c, and with the 1/4 out there also. Just double check it, is that right? I think it is. Cosine, zoom, 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 back inside, boom, boom, yeah, good. Okay, so that's pretty much it. That's pretty much it, okay? So, I mean, you want to do one? Oh, well, okay, well, let's do one more together. So, this is sine cubed x cosine x dx. All right, here's the thing about this is, it is possible to do all of them in your head like this, but I discourage it. And let's see, who are my like weirdos who never do anything? One, Yob a little bit, Robbie, others. Okay, there's a method which makes the problem easier, and the method is called the method of use substitution. Basically, this method, though strictly speaking logically it is optional, it is very, very helpful and very recommended because it just dumbs down the process a little bit and you just kind of keep track of all the things so you don't have to worry about them too much. And here's what you do. Off to the side, you just pick a new variable, u, and you let u be the inner function. So what should u be in this case? No, the inner function which you went back and took the derivative of. Yeah, we should let u be sine. And then differentiate this with respect to x. Well, we get du dx is, derivative of sine is cosine x. And now, because this seems to be the thing to do, we can just swing that dx over, because why not? And now we will rewrite the antiderivative problem in terms of u's. So instead of writing this as sine cubed x cosine x dx, I could instead write it as almost. Sine cubed would become u cubed, and cosine x dx is du. Ta-da! So now it's just a u cubed du problem. What is the antiderivative of u cubed du? 1/4 u to the 4th plus c. Right? What was that notice? Caption on video. Okay, and so the actual final answer is 1/4 sine to the 4th x plus c. Yeah, you could have done that entire problem in your head by yourself without this method, but this method just helps organize your work essentially so that you don't like lose the constants and stuff. What's up?
So why would you choose you to be sine?
I chose you to be sine because experience, and I just knew that it would work out that way. And a lot of this is going to be one of those things where you're going to be really terrible at this at first. It's actually kind of cute, like how bad you guys are at this. And then you're just going to quickly get better and better with just like endless practice of something. How do I know that you need to be sine? The general kind of idea is I want u to be like the inner function, and then du is like the, you'll just get the hang of it.
But that's not the, okay.
If you set u to be equal to cosine, it's just like won't work.
Okay.
All right, so really fast, on the next page, I just would like to make you aware of certain people and certain teachers do this with different styles. So there's some style lists. So what I'm now going to present are 3 methods of doing the exact same thing. And these methods are barely indistinguishable from each other. Yeah, I'm going to go back in a second. These methods are barely distinguishable from each other. So method number 1 is like more or less the method I use. But they're all really exactly the same. But anyway, Method number 1 says, well, I look at this thing, and so I have square root of, or I have the antiderivative of root 2x plus 1 dx. And here is what I'm going to do. I'm going to set u to be 2x plus 1. And then I'm going to think of this, I guess, explicitly. I'm going to think of u as like a function of x. Can you move the camera? Like 10 minutes ago, I should have done that. I'm going to think of u explicitly as a function of x. And now, if I differentiate both sides with respect to x, then I get du dx equals just 2, right? Okay? And thus, du equals 2 dx. And when I look at the problem, I notice that what's missing is a 2, right? So I stick in the 2, I undo the damage with a 1/2, and now I'm basically ready to go. This problem turns into 1/2 antiderivative. Well, instead of square root of 2x plus 1, it's really like the square root of u, and in place of 2 dx, I write du. Are we cool? So am I going too fast, or just right? Too fast. Well, I had du dx, so u is like 2x plus 1. So the derivative of u with respect to x is just 2. Then I multiply both sides by dx. So there was a 2 dx there, so I just substituted du. Did I answer your question? Oh, like what I'm supposed to do now? Oh, well now I have an antiderivative which is written all in terms of u's. So I just do it. So this is really just like, I'll put it in an anti-differentiation friendly form. This is just u to the 1/2 du. So what is the antiderivative of u to the 1/2 du? Yeah, you go up a power to 3/2, and then you divide by 3/2. So it's going to be 2/3 u to the 3/2 plus c. And so, yeah, because c is just constant, so it's like whatever. So the answer is 1/3 2x plus 1 to the 3/2 plus c. And again, if you're skeptical, you can differentiate and just check to see if it works. So that's that. Okay, method number 2 is basically the exact same thing, but in method number 2, it's like really the exact same thing. But in method number 2, I just kind of just like, it's like a little bit of a shortcut. I just go 2x plus 1, and then I just say du is just like 2 dx. And just never mind the whole like du dx thing. And then you just kind of like take it from there.
Wait,
like,
what? That's
like,
the same thing.
It's the same thing. Yeah, it really is the same thing. Okay, method number 3 is also the same thing. I mean, it's really only one way, but it's just different people write it differently. Method number 3 is actually kind of slightly different. Method number 3, yeah, you still write u equals 2x plus 1, and yeah, you still differentiate, so you get that du equals 2 dx. But now, some people like this better. Now, instead of doing the like put in a 2 and undo the damage, you can just solve for dx. So what is dx? Du over 2. And then you can just directly substitute that in. So this becomes root u, and then in place of dx, I just put du over 2. And of course, it's all the same thing. I keep getting all the ways. Okay, good. You have 20 minutes. Perfect amount of time. Try to do as many problems as you possibly can.
Hey guys.
Go.
Power Rangers Unite. Oh wait, so we're supposed to thumb turn? Wait, how do you turn the thumb?
Leave the camera on and I'll deal with it. Or did you turn it all the way?
No.
You guys are
Okay.
not active participants.
Oh, if you press to turn it.
Yeah. Yep.
That's why you make the camera zoom and turn on the magic.
Okay, well that will be part of our San Francisco startup.
Just like have like a thing on you that like tracks where you are in the room and it'll follow you.
I like the thing. So you just get some some drone like hovering mid-classroom, following my every move. Or we just need a room. The nice thing about 10 minutes is don't pay me.
Oh my god.
Slavery does not mean innovation. You need to pay people in order for real. It's great about capitalism.
1/2 arcsine, 2 x, right? No, I just in my mind I feel like that's straight. No.
Oh, and the other thing to say about this is some personalities have trouble with this because you just like don't know what to do at first. So you have to be comfortable with just being wrong and being lost. This is one of those times when it's good to be like, it's good to just be someone who's just like, I don't know what I'm doing. I'm just gonna try some crap, like Griffin or something. Or like Nick Healy. Those two are like that. So yeah, this is the time to be like those people. Don't feel like you need to be perfect. Don't worry about messing up. Just try some things and just sometimes it will work and sometimes it won't.
Alice, stop being that personality. Just do it. Do it. Do it.
Wait, what is
Just do some crap. I like
What happens to the
the X level.
No, it's because it's like.
Oh, it's like 1. It's like 1. Okay, Alice, roll it.
And then you end up
Put a negative 8 with negative. No, we have to actually do substitution. Negative 1 8 x, right? No, because the x is on top. That would be negative 1.
Do you want to repeat it?
Wait, what'd you do with the X?
Ethan, what did you do?
With the X.
Wait, so you
Yeah.
I tried it. Wait. Try harder.
So I did one.
Try harder, Sandy.
You want to do the first one together?
Yeah, I think it's 3.
So the first one is x over root 1 minus 4x squared. Is that what you got? Or that is the problem, right? Okay, yeah. So that should be what's on your paper. All right, how do we do it? Again, you have to be a crime scene investigator. You don't have to pay attention to me. Can you like whisper a little bit ish, like not? So how do we just crime scene investigator? You are, or like it's more like Goldilocks. Remember what? Doesn't she say something when she goes like, no, the bears. The bears say something like, looks, someone's been sleeping in my bed. It's like that. But here it's like, looks like someone did some chain rule here. And it appears, after some experience, you get the idea that like, well, what is the derivative of 1 minus 4x squared? It's negative 8x, right? And so it does look like someone did some chain rule there. It looks like that x is give or take a constant, the result of someone pulling a chain rule on the stuff on the bottom. Follow? That's the only intuition you need to know that therefore I should set u to be 1 minus 4x squared. Robbie, you need to do the u's, man. I know you're going to try to do the whole thing in your head. Please don't. Please do it. Okay, once I set u to be 1 minus 4x squared, then I know what du dx is. Du dx is negative 8x. And so du is negative 8x dx. You guys with me? Once I have that, then if you do it my way, I stick in a negative 8. I undo the damage with the negative 1/8. And now I rewrite the antiderivative all in terms of my new variable u. Well, negative 8x dx is now exactly just du. Follow? You guys all mostly get this already? Okay, so what I have is a du over the square root of u. And now I've successfully rewritten the problem as a u problem. So now I rewrite this in an anti-differentiation friendly form. This is really like u to the negative 1/2 du. And how do I anti-differentiate u to the negative 1/2? Go up a power and then divide by that power. So it's negative 1/8. Up a power would be 1/2, and then dividing by half is like multiplying by 2. So my final answer is negative 1/4 u to the 1/2 plus c. But of course, u is just a fake variable that I made up for this problem. So my actual answer is negative 1/4 square root of 1 minus 4x squared plus c.
That's what I got.
Good.
Wait.
Awesome. Keep going. Yo. Question about this? Question about the shoe problem.
Couldn't you set u equals 2x and put down assumption as like arc sine?
Nope, I don't think so.
Wait, should 2 be negative?
Doesn't that look a lot like?
It looks like it, but
Can I
it.
get that chair?
Alright, keep going. Try to do as many as you
Like
can.
the rule is you add 1 and then.
Figure this one out or just give up? Oh, yeah, good. He's on it?
Wait, for however 5 you get to use u?
Not really.
Yeah, if you're really smart, you can sometimes like skip a step and just like do it.
Yeah, it was like number 5 is perfect.
Yeah. I always do the U, but you know. Alright, guys, you're allowed to do number 5 in your head. That's it.
Number 4, I couldn't think of what the u is. So just, that made it interesting.
Problem is, there's always one guy like you every year who's just like, oh, I'm really smart. I can just do this in my head. Yeah, and then when you can't, then you just like fall apart. Also, you might just have the general gist, but get like all the constants wrong like every single time, which is also bad.
Wait, is it possible that something could anti-differentiate these derivatives?
How it goes. I say what if you just substitute? I don't know why you say.
Okay, number 6 is an example of how life is hard. So you just have to try things and don't give up.
Don't give up. Ever.
Try different things. Work together. Some of you should be able to figure it out.
Yeah, because I'm so
Raymond's just taking the route through life where he skips things that are hard and hopes other people do it for them.
That sounds like a good group.
Yeah, so trying to let u be tan is just not going to work, right? Because du would be secant squared. There's just no secant squared there, right? It's just not there. If it's not there, you can't make it happen. So you have to try something else. Yeah, it's hard.
Wait, nothing ever becomes like u to the negative 1. U to the negative 1 is
Wait, so what's an idea? I want to shepherd you through this slightly. Yeah, it's me, you got it.
You can x to the negative 1. You can x to the negative 1.
Right, just write it as sine x over cosine x. It seems like a good idea. But now, can you think of a substitution that works?
Yes.
Oh, that's just cosine.
Josh, shut up.
Then yes, that does work.
That's not my problem right now. Okay? Really. Wait,
What? Jesus, what are you talking about?
well, this season, you get, I don't know.
So is there one of those that seems like it would be a good idea to let be u?
Secant x is tan x, and then
Cosine x.
Cosine. Why cosine, Emma?
Because you need to get the dx in the top.
Yeah, because the dx needs to be in the top. So she just kind of like gets it. The rest of you, you'll just figure it out when it slowly comes to you how the world works. So yeah, you let u be cosine. If u is cosine, then just take it from there. Do the problem, see what happens. I'll be right back with your WALPS packet.
it's like really not my fault, okay?
It's actually not negative one over here. I ended up with negative one.
I understand how the world works. You'd be like,
Oh, how do you
so then.
You have to multiply here, minus 1. So if it's negative minus 1. You have to multiply that by negative 1.
Wait, well, that was 6.
Sin x dx, right?
I thought you said.
No, pure in isolation.
I don't care. For number 6, you get
Ew.
negative, you get like
Why'd you
the
move?
negative 1, right?
Why did you move?
How do you dx? What is that?
That chair.
Oh,
It's comfortable. What do you mean?
Very comfortable over there.
that was taken.
Okay, did you figure this out?
Wait, what's the u over u?
If you let u be cosine, then du is.
Nobody has it.
Oh, ln.
And thus I wish there were like a negative in there, right? So if I wish there were a negative, I just stick it in, undo the damage with a negative on the outside. Now can I rewrite this all in terms of u's? I can. And it's just the opposite of du over u. And what is du over u? What? Oh yeah, but this is just one you're just supposed to know. Du over u. It was in the homework today. Probably. Yeah, it's like natural log, right? That's just like a thing to know. But with the absolute value for the reasons we discussed. So this becomes negative ln absolute value u plus c. Right? Say right.
Right.
Okay, and then so the actual final answer is negative ln absolute value cosine x plus c. And if you left it like that, I would be still perfectly happy, but most textbooks don't do it that way. Most textbooks continue to pull a fancy move, and that happens whenever there are logarithms involved. People are just, it's like a big show-off game. So what's one more thing we could do here?
We can take out that.
No, we can't take out the absolute value because, no.
Cosine squared over.
Square and divide by 2.
Cosine to the negative of?
What? Pop the negative up. Yeah, we can pop the negative up. That's like a -1 coefficient. So this actually becomes ln absolute value cosine x to the -1 plus c, which is, boys in the front, head down for a second as I finish this problem. So the actual way that you will find this in most places is that the answer to this problem is the natural log absolute value secant. Okay, good. Keep going. More problems. Do as many as you can. 6 minutes. Come on. Go. And just keep doing this. Don't stop. All through 9th period. All after school. Oh yeah. Actually, you guys are. We have after. No, today's Monday. Yeah. You should all come after school on Tuesday. Here's the problem. We're going to Wallops with a giant packets of these, And everyone else is going to have like a whole nother day where we just like go over the tons. They're going to be like way, way better at it than you are. So your homework, which is going to be due Wednesday morning, is to do some problems from the textbook, and also, yep, that's right, and also pages 1 through 4 of this packet. So you should all come after school tomorrow, or work on it during lunch, or do whatever. Just like do as many of these as you possibly can.
Like second.
Wait, 1 to what?
Pages 1 through 4 of this thing.
You two was like right.
I know.
It's a lot of work. Yeah, it's great. How do you do 7? You have to try some things. Does it look like some change will happen there? It really doesn't at all, does it? So try something else. You have to do something kind of creative with that one.
Wait, split it to like cosine square and cosine.
Yeah.
No, but like.
You want to think of something creative to do with cosine cubed?
Yeah, 1 minus 2 sines. No, 1 minus sines.
Wait, isn't that like?
Yeah, 1 minus sines.
Yeah.
Yup. Yup, table figured it out.
Oh yeah, that's all like.
Try some tricky type stuff with this. Can you rewrite cosine cubed? That seems like a good idea. What does that get you? Yeah. Is that something I would like? Now does it look like some change will happen there? Yeah, it does. I know, it's really hard, yeah. Some of them are easy, but some of them aren't. Yeah, anti-differentiation is hard. Mr. Stein does this, like, we used to teach analysis 1A for like a really long time, he doesn't anymore, and he used to assign his class this activity, which I thought about just ripping it off of him, but I tried to come up with my own jokes. Anyway, his activity was, like Schaefer and people like that. Take a tube of toothpaste. This was the activity. Take a tube of toothpaste, and you go home, and you take the entire tube of toothpaste, and you have like a piece of like wax paper or whatever, right? And you're supposed to squeeze the entire tube of toothpaste out onto the wax paper. That is pretty easy. That is like differentiation. Putting it back in, however, without the use of scissors, is like anti-differentiation. And then he would make them like get the toothpaste back